Okay, hey guys. So we're starting. I just logged on about a minute early. So if I have a few people who are gonna join in on this, you might hear a little chime. Those are people joining in on the meeting. We're covering chapter 5 today for Intro to Psych. What I'm going to do is I'm going to give just a minute or two for a few more people to chime in so that it won't be distracting. And what we'll do is we'll go ahead and I'm going to pull up the lecture slides. You can follow along with the lecture slides. I have a few notes of my own that I'm going to put in here, so that way, I'm going to record this. So later on, when you are, looking at this, if you need it for, extra help, you can go ahead and pause it and look at the notes if you need to jot those down. So remember that I am recording this. So if you come in, if you're coming in late into this, or if you just tuned in and you have to cut out early, remember that this is being recorded, so you should be fine in terms of getting that content. So I'm going ahead and what I'm going to do is a couple things here. With Zoom, you can do screen share. So I'm going to kind of jump back and forth between slides and notes and things like that. Right now I'm going to start with the chapter 5 lecture slides. So if you can pull those from Moodle, follow along, jot your notes down. Obviously you have the slides, so you don't need to write every single thing down. And I'm not going to cover every single slide in this. What this is essentially covering the most difficult parts of the most difficult concepts of this chapter. Learning in it of itself is a great topic. But unfortunately, some people find it a little bit difficult when learning about some of the terms. So that's why I want to kind of bring this out and make sure that everybody understands kind of where we're going with this. So what I'm going to do is I am going to pull up the lecture slides so that way you guys can see those. And like I said, I'm going to kind of jump back and forth a little bit with some of the notes so that way you can have some of these terms defined. So I'm going to kind of put it here. You guys probably can see the slides on the side. So I'm going to make this a little bit bigger so that way you guys can see the whole thing. Now, remember, if you have any questions throughout this, let me know, and you can kind of pop in, of course. You can pop in with a question if you have it, and I am happy to answer those questions, or you could do through chat. So I can actually hear you, I can actually take you off the mute, or you can go through chat. So, okay, so let's take a look at this through these slides. So when we're talking about learning is this change that actually happens in the brain. It's, you can actually see a change in behavior, you can see a change in knowledge, and that is a direct result of experience. And we're going to learn a little bit about some of the behaviorists and other scientists who came in and really paved the way for what we have learned about learning. We know now in neuroscience that, of course, when you learn something new, that actually does change the neurons or the cells in the brain. And so we've learned a lot in a short period of time about learning. And a lot of what we learn about learning is actually through animal research. We learn a lot through research on rats and pigeons and things like that, because we can actually dissect the brains and see exactly where, metabolically speaking, that's actually occurring in the brain. Now, we're going to talk about two types of something called conditioning today. Now, conditioning, as you see here, it's this associating an environmental event and a behavioral response. And we're going to talk about classical conditioning and operant conditioning. They're not difficult terms, they're not difficult concepts, but when you read them for yourself, sometimes it's difficult to kind of put it all together. But when you get really good examples, then it's a lot easier to navigate. Now, classical conditioning, this started with Pavlov. Now, Pavlov was not a psychologist. He was actually a physiologist from Russia. He was studying digestion in dogs. He was not studying behavior in the sense that psychologists do. He was not interested in that. But it turns out that one of his experiments on digestion gave him some information, and he made this observation that animals, the dogs that he was studying, they were actually reacting behaviorally to something that he was doing. And so because of that, he thought, okay, well, let's take a little look into this and let's see what's going on. And so that's when this association that he made, that that doing something in the environment can actually produce an existing behavior. That's where this idea of classical conditioning comes from. Now, one major key point of classical conditioning is, and is also called Pavlovian conditioning, because he was sort of the one that began it, that really discovered it, I should say. He realized that the behavior was a reflexive behavior. Okay, so a reflexive behavior might be something like fear or happiness. It's sort of a reflex. It's not something that you have to learn to do. And specifically with dogs, he was interested in how much they salivate or drool. And when you talk about a reflexive behavior, think about when you are at a restaurant and you're super hungry and you are looking at the waitress coming by and she's got plates of food and you're like, oh God, I'm so hungry. And you see this big giant juicy hamburger. And if you're a vegetarian, let's say it's a bean burger, I don't know, something delicious that you find really, really good. And let's say you're so hungry. Well, a lot of times what ends up happening is as soon as you see that food, you start to drool. You feel like your salivary glands, if I can say it, are kind of, on really, really taking into effect. You really, really want that food and you can't help it. It's not like you say, you know what, I see that food. Okay, mouth, let's start drooling. You don't do that. It's just a reflex. And so Pavlovian or classical conditioning comes from this sort of reflexive behavior in response to something in your environment. So this is something that, of course, Pavlov really, really noticed. So there are a few terms that are really important that you really need to be familiar with when it comes to classical conditioning. And what this is kind of the whole thing when it comes to the process. Okay, so the process of getting an environmental cue and getting this reflex to respond to this. Okay, so we always start out with unconditioned stimuli, unconditioned response. Okay, and one thing that I have off here, I'm sorry, I'm moving my laptop so that way it can breathe a little bit. Making a lot of noise. I just don't want to make sure it doesn't heat out. Okay, so when we start out, we're dealing with unconditioned stimuli, unconditioned responses, and something else that I don't have here, which is a neutral stimulus. Okay, so starting out with an unconditioned stimulus, this is something that naturally produces or elicits a response without having to learn it. Okay, when you see the food, that's the reflex. It makes you drool. Okay. The unconditioned response is the response. So the unconditioned stimulus is the food, because that is causing you to drool. The drool is the unconditioned response. You don't have to learn it. It's reflexive. It's what is produced when you see that food. Okay. Now, when we start getting to the conditioned part, that's when you need to actually train the response. Okay. So we're gonna move to this next slide so that you guys can see how Pavlov did this. Before any conditioning occurs, before you're training anything, we start out with these unconditioned stimuli and responses. Okay, so before conditioning, Pavlov had this dog and he rings a bell and the dog just looks at him. Okay, it's like, what? It's a bell, who cares, right? So the bell does nothing, it's neutral. Okay, so Pavlov's ringing the bell, the dog looks at him. Okay, rings the bell, dog looks at him, does nothing. Okay, now that's before conditioning. Before conditioning, you show the dog some food, okay? And in the case of Pavlov, it was actually meat powder. You show the dog food, okay? That is an unconditioned stimulus. That stimulus itself, okay, does not need to be learned by the dog. It's going to produce a natural reflex, which is salivating. And the salivating or drooling is the unconditioned response. So before any conditioning occurs, Pavlov showed the food to the dog started salivating, okay? The unconditioned stimulus was the food, unconditioned response was the salivating. And of course we have the bell over here, which is neutral, it has done nothing. So then Pavlov was like, he started noticing that when a particular bell rang, the dog eventually made an association between the bell and the food and would salivate, okay? So in order to make this happen, he would take a bell and he would ring it and produce food, okay? The bell is still neutral because the dog's not going to respond to the bell yet, okay? Pair it together. Pair the neutral stimulus, the bell, with the unconditioned stimulus, the food, together over and over again. Food, bell, food, bell, food, bell, food, bell. And the dog is going to salivate because he sees the food. So at first, it's unconditioned response. Keep doing it. Bell food, bell food, bell food, bell food, bell food. Eventually, the dog doesn't need the food. Remove the food, ring the bell, the dog would drool. What has happened here is conditioning has taken place, okay? Now the bell is a conditioned stimulus and the salivation is the conditioned response, okay? It no longer needs the food in order to produce that response. You might see this happen if you have a dog yourself or a cat and you have a can of food, okay? And you take the can of food and you put it on a automatic can opener, okay? At the very first time that the cat or dog experiences this can opener sound, it's not going to know what it is. But over time, as it associates the can opener sound with you giving it food, it's going to now start to get excited when it hears the can opener. At first, the very first time you do it, the dog or cat has never heard that before, and so it's not going to respond. It's neutral. But over time of pairing these two things together, the dog or cat will then make the association. So remember, classical conditioning is all about a reflexive response, okay? Something that the animal or person can't control. We also see this in humans plenty of times, okay? For example, a reflexive response is happiness. So sometimes we can associate smells like perfume with happiness, with a reflexive response. So let's say you have a grandmother who wears a particular perfume, and growing up over the years, you've associated that perfume with your grandmother. So anytime you smell the perfume, you have the same feelings that you have whenever you were with your grandmother. And let's say your grandmother made you very happy. And so when you smell the perfume, it actually can make you happy. I'm checking my laptop. It's still feeling kind of warm, so I'm just making sure that it doesn't. Sorry about this. Okay, it's making a lot of noise. I don't like that. There we go. Okay, so if anybody has any questions about these terms, this would be a good time to ask. But if not, we'll just move to the next set of terms. So I don't hear any chimes and I don't see any chat. Let me pull this off really quick. I have a chat feature on here and I want to make sure that it's up and running. So that way, if anybody has any questions but doesn't want to actually come in on the chime, they can do that. I don't see anybody. I don't see any. Okay, I'm going to pull the video up. I'm going to, hold on 1 second. Sorry, guys. Here we go. Got chat. Okay. So. Okay, I have my chat window up. So if anybody looks on their screen, they should see that they do have the chat feature. They need to. So I'm going to put on here, I am available on the chat. Okay, I'm gonna pull off and I'm gonna allow video for just a quick second because I can't see or hear anything. I'm on kind of darkness here, and I want to make sure that everyone is able to chime in if they have questions, because this is a really good point if you guys have questions. Because my chat's not popping up right now. Okay. Now I'm sending a chat to Mason. And if you could chat back, that would be great. I just want to make sure that you guys can see me. Awesome. Thank you, Mason. Okay. Can Madeline, Allie, or Judy, can one of you guys chat? Hit a chat to me and make sure that I can see this, please. The sound isn't coming through. Okay, that's good to know. Sound is working great. Okay, great. I'm seeing everybody. Excellent. Thank you, Madeline. Thank you, Judy. Okay, so I just want to make sure that I can see everybody. If you have questions, of course, just let me know. I just didn't know because I had you muted if that was going to go away. Okay, I'm going to keep this window up. Sorry about that. Okay, all righty. Now, so since everybody seems to be pretty good with that, we're going to, I'm going to move you guys to, we're going to move to the next slide, which is the factors that affect conditioning. Okay, so I have these 4 things listed here: stimulus, generalization, discrimination, higher order conditioning, and timing. And I'm gonna move to my full screen. Actually, no, I can go ahead and move just to the document here. And I wanna show you guys this real quick. And these are the terms that, and like I said, you don't have to immediately, try to write these down and scribble. You should be able to, pause the video later on and get this down. But what these few terms are, the first one is stimulus generalization. This is when conditioning has occurred and the animal or person starts to associate the, for example, the bell ringing. If the dog, Pavlov's dog, would salivate at the bell, okay, he's conditioned. And then when your phone rings, the dog salivates at the sound of your phone because it sounds kind of like the bell. That would be a stimulus generalization. The dog is generalizing the stimulus. Anything that sounds remotely like the bell is going to produce that response. Stimulus discrimination is the exact opposite of that. This is when the dog can isolate the ringing of the bell and only respond and discriminate to that particular stimulus. So when your phone rings or when it hears a chime, it does not salivate because it's learned that only the bell is to be associated with the food, okay? So this generalization versus discrimination. Higher order conditioning is when the animal learns to associate from a conditioned stimulus. So it's a higher order. It doesn't need the dog, for example, Pavlov's dog, does not need the food again in order to associate with another stimulus. So let's say the dog associates food with the bell, okay? Now we have this conditioned stimulus is the bell and the conditioned response is salivation. Well, if you pair the bell now with something like a clap, okay? And you do that over and over again, the dog will then associate clapping with the bell, with the food. So it's a higher order conditioning. It doesn't need the food again in order to make that association. So now only when it hears the claps, it'll salivate. So it associated that bell and the clapping together. Timing is really important when it comes to conditioning. And you can't when you're trying to condition a dog to associate the bell with food, you can't produce the food and then ring the bell 30 minutes later, or ring the bell 30 minutes before and then produce the food. It's got to be really closely timed. Okay, so the conditioning occurs best, it's most effective when you can present the conditioned stimulus immediately before an unconditioned stimulus. Okay, so that way it starts to associate those together. And we're talking about a half a second to just a few seconds here. So timing is very important. And you need to make sure that the animal or person associates those things together, so there can't be a big lapse there. There's a couple of things that violate this rule, and we'll talk about that in a minute. But that is something that is generally known in conditioning. Now I'm going to move you guys to back to the slides. If I can find them. Let's see, here we go. All right, so you guys should be back onto the slides now. So we talk, so a couple of things that, and I'm just going to very briefly talk about these because, you know, just understanding the kind of basic concept here is what's important. So we have what we refer to as extinction. And that is that over time, the dog is going to stop salivating at the sound of the bell. Okay. Over time, he's going to realize I don't get any food. So there's no point in me in doing this anymore. I mean, he doesn't really think like that, but that's what happens. So over time, we see this extinction occur. And then it's just a gradual weakening of the response to eventually it goes away. But then something really interesting happens here. And this is something called spontaneous recovery. So here's an example. This table here shows these trials of ringing the bell, okay? So you see in the column here, 0, 0, all the way to 1.0. These are the cubic centimeters amount of drool that was collected. And as you can see here, the first few trials, you know, that dog is going to salivate a lot, okay? It's going to hear the bell and it's going to be like, yeah, yeah, yeah. And it's going to salivate. Every 3 minutes, a new trial occurs. And after, you know, about 4 trials, and we're talking about 12 minutes or so, to the 5th and 6th trial, you're seeing that the salivation stops, okay? It ends. We see extinction of this conditioned response. But something that really, really bizarre that happens, and we don't have a lot of really good explanation for this yet, is this spontaneous recovery, okay? And that is without providing the food again, just by ringing the bell, eventually after about 2 hours, the dog will start salivating again. Now notice it's not a lot, okay? It's less than 0.2 cubic centimeters, but it is enough to show a significant response. So this is a conditioned response that has gone extinct and over a period of time has resurfaced spontaneously. It's recovered that response. And if you continue those trials, it'll gradually weaken again, but we do see this very interesting spontaneous recovery. Okay, so let's see. Pavlov dealt with dogs, okay, and was interested in digestion. Watson, John B. Watson, was a psychologist who was interested in human behavior. So he wanted to take Pavlov's work and, you know, think about it in terms of humans. He founded the approach called behaviorism, and was a big, you know, factor in this. And so he essentially wanted to show that all of human behavior resulted from conditioning and resulted from learning. And so he actually started the experiment that we refer to as Little Albert. Now, today, Little Albert, this experiment would not be considered ethical because he didn't really take, this was done a very long time ago. And of course, during this time, ethics we didn't have a board of ethics to approve research. We didn't have the kinds of things that we have now. So this is going to sound kind of mean, and it is. But of course, Watson believed all in the name of science. And so essentially what he did is there was a nurse who was worked in the same hospital as Watson, and she had a young son, which they referred to as Albert. a baby. And he said, why don't you bring little Albert and we'll do some experiments on him? And she's like, okay, sure. And so that sounds like a great idea. And so what Watson wanted to do is he wanted to elicit this reflexive or emotional response of fear in little baby Albert. So he started, and you can actually Google some footage. There is footage of these experiments. They're grainy and black and white, but it does show little baby Albert, and it shows, you know, what he was exposed to. He was exposed to rats and bunnies and things like that to see how he'd react. And, you know, just like Pavlov's dog, we have the same sort of case where we have something that doesn't produce a response. And in this case, it was a rat, a white fluffy rat. Albert had never seen a rat before, and it didn't scare him. It didn't upset him. So this was neutral. So the rat did nothing to him. So he would sit, and you can actually see video of him playing with the rat. And then Watson said, okay, well, what's something that babies are afraid of? How about extremely loud, unsettling noises? And so what he did is he took a metal bar, a steel bar, and he hit that bar with a hammer very loudly. And of course, that scared little baby Albert. So that was an unconditioned stimulus. Okay. The baby didn't need to learn to be afraid of the noise. He hit the bar, and then the baby would start crying. Albert started crying. And the reflexive response was crying or fear. Okay. That was the unconditioned response. Over time, of course, pairing the rat, which is originally neutral, put it in the lap, and then clang, 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 and do this enough times, of course, it's going to produce a response. At first, because little Albert was not scared of rats, it was an unconditioned response, the crying and the fear. Okay? But over time, they took away the loud noise and just showed the rat and gave it to him, and he would just immediately start crying. And at that point, the neutral stimulus then became conditioned, and the response, the fear response, is now considered a conditioned response. Little Albert actually generalized this to not just white rats, but white rabbits. Anything furry and white, he would actually associate with this fear response. I've even read that he was scared of Santa because of the big white bushy beard. He actually generalized these different stimuli to the white rat, to the loud noise. So higher order conditioning, of course, also occurred with other experiments. But of course, we are not going to we're not going to talk about those extensions. But you know, just to kind of get the idea of what exactly happened with little baby Albert. Now, of course, today, you know, you would say that that's not a really nice experiment to do. That's really sad. They did not uncondition him. You can actually uncondition people. It's something that you do if you have a trauma. And they didn't do that with him. We don't know who little Albert was. There is some speculation that he might be, he would have died by now because he would have been a lot older, but they speculate that he was a particular guy. They tracked down who they thought was his mother because she moved out of the area directly after these experiments. And it turns out that the one thing that all the family members said about this suspected baby Albert was, as an adult, that he was terrified of dogs. And so it kind of made sense that he'd associate the rats and the white fluffiness with the dogs, and then that maybe generalize that to a whole species. So that was kind of sad. But we did learn a lot about learning, and we learned about, of course, classical conditioning with little baby Albert. So was it ethical? No. They should have at least tried to reverse the fear. But of course, we know better now. Now, I've gotten from Mason that his sound is not working well. If you're having an issue with the sound, if you could shoot me a message. Hopefully it's going to be okay with the recording. And I'm assuming it's probably low, but if you're having an issue, just shoot me a message so I can know. Now, okay, so when we take this and say, what do we know with classical? What do we do with classical conditioning? How do we know about it? And how do we apply it? Well, it turns out that you can use this in advertisements. And this is where we see things like associating cars, like really sexy sports cars, with women and in sexy women. And so then we get this kind of sexy image. And then we see, advertisements using and pairing these things together, the sexy car and the sexy woman, and over and over and over again. And you start thinking, okay, well, cars are sexy. Sleek lines, like a woman, it looks great. And so this advertisement, I'm getting a message on my Zoom. I might have to come out and come back in because it's telling me that I have a limit. So I might only go to 40 minutes and then I might come out of this. I'll let you guys know. Okay. So sorry about that. I did not, never mind. Okay. So it went away. Okay. So looking at advertisements and things like really old advertisements, you could see, like, for example, with Pepsi, they would do things like, if you want to be liked and if you want to be an awesome person, why don't you drink Pepsi? Because then that will make you more sociable. That will make people like you. And so what they're doing is they're playing into this in this reflex of you wanting to be loved by others. And this is an actual basic need of wanting people to like you and wanting to be to feel accepted and needed. And so advertisers actually would play into this and use classical conditioning, these feelings of happiness, feelings of fear, feelings of anxiety, and they would pair products with things and get you to feel something. And that's how advertisements usually work, to get you to actually do things, buy their products, basically. Okay, so another thing that we can think of when it comes to reactions that we experience. For example, you can experience trauma if you are in a car accident, and let's say you don't like to go into cars anymore, or you get really fearful when you're around the area that had the car crash. You are actually associating these emotional responses, these reflexive responses of fear and anxiety with an event that happened. So if you're afraid to go into a car, if you're afraid to go in the same area, this is actually explained by being classically conditioned. Now, this would be an example of something that doesn't need to be paired repetitively. This would be something that kind of breaks that mold. It breaks that typical factor that needs to be involved in classical conditioning. Usually it's a pairing of a neutral stimulus and an unconditioned stimulus over and over again. But occasionally we do actually see that something like an extreme accident or extreme trauma can produce these responses once, and you only need that one pairing. And then when we talk about sort of how this happened, why does this happen like to humans, and how does this occur? Why does this occur? One interesting thing, I like to think about things evolutionarily speaking. So, why is it that humans experience this? Why is it that, how is it that this shapes us as human beings? And so one thing that we can use is something called a taste aversion. So, I think that for many of us, we've all at one point or another experienced food poisoning, and that really sucks. Obviously, for most people, okay, they eat this food. Let's say it's, I don't know, Taco Bell. Let's say they had a burrito at Taco Bell, and they had this burrito, and they got violently ill after. Okay. We associate our violent illness. Okay. We try to figure out why is it that we're sick. Okay. And we associate it with the food. So in this case, I say, okay, well, the only thing that I ate was a burrito. And that makes sense, right? So then anytime you're around the burrito, you feel a little queasy. You're like, you know what? I'm not really into eating this burrito. Now, there are some of us out there that love burritos so much, or tacos, or whatever else food that can make us sick. We love it so much that we still don't care and we'll still eat it. But in the case of in the case of food aversion and illness, a lot of times we end up really just being averted to having aversion to this particular food, and you don't want to eat it again. And evolutionarily speaking, this makes sense because, when you are, let's think back to not cavemen, because that's really not a great way to describe it, but early humans, and they're, eating different foods. And if they ate a particular berry and the berry made them ill, obviously you don't want to keep eating those berries because you don't want to keep getting sick. So we've developed this thing called taste aversion, where you eat something and you now no longer want it because it grosses you out. Well, that's good because it keeps you safe from eating it and getting sick again. This does violate the standard conditioning model because, of course, you are not pairing these things very closely together. So classical conditioning requires you to pair this, within a half a second to a few seconds. Well, maybe you ate the burrito at 2 p.m. and at midnight you start throwing up. This violates that model, and it still is something that's considered classical conditioning, because it can take place hours in between the pairing, and you're still going to pair them together. We also can explain this through conditioned fears. If you are around a particular animal and that animal scares you or bites you or something like that, that can elicit fear. We can actually see it in other people. Some people are scared of dogs, for example, because they see their parents scared. Maybe their mom's scared of dogs, and so they actually see the fear with her, and then they can use that association themselves, and that conditioning has occurred. And this idea of biological preparedness is essentially, improving your survival, improving human being survival. So we have these kind of particular basic fears that many people are afraid of: heights, tight spaces, spiders, snakes. And that's because obviously those things can kill you or hurt you. And so those humans that, thought that heights were great and fell off of something really high obviously didn't survive to continue on. And the idea is, over time, these natural fears sort of prepared us biologically for better survival. Okay, so that's the idea behind classical conditioning and phobias and how you can sort of apply it. Now, one thing that I want to kind of move to is, from classical conditioning, understanding operant conditioning. So remember, classical conditioning and Pavlovian conditioning, same thing, okay? This is just a different term for it. Classical conditioning is all about eliciting a reflexive response, okay? Operant conditioning is about consequence and choice, okay? Behavior and consequences. So you're actually choosing to behave a certain way. It's not a reflexive response. It is something happens in your environment and there's a consequence for that. So Thorndike was one of the first psychologists to actually study what we refer to now as operant conditioning through both trial and error and law of effect. Now, law of effect is actually very simple, and we are going to go into much more detail about what law of effect really is, and we're going to place some different terms to that. Law of effect is sort of its very basic preliminary status in terms of what this particular thing is. So law of effect is essentially, and we're going to place new terms on this. So it's going to sound very familiar, but it's now going to get a little bit more specific. Law of effect is that if you have a response and it's followed by something that's satisfying, something that makes you happy, or something that's pleasurable, okay, then that response is going to be strengthened and you're going to be more likely to do it again in the future. Okay, so let's say that you make straight A's on your report card, and your grandmother gives you $50. Okay, that's very extremely satisfying. You're like, "Ooh, that's super. I'm going to do that again. I'm going to make straight A's next term." Okay, so remember, the law of effect is very simple. The second part of law of effect is any response that's followed by a dissatisfying effect, like something that hurts or something that you don't find satisfying, then that response is weakened and you're going to be less likely to do that behavior again. So let's say that you go to the store with your mom and you open up a candy bar and start eating it in the store, and your mom is not a fan of this and she smacks your butt in the middle of the store. Okay, you're going to be a lot less likely to want to open up a candy bar and eat it in the store again, because the response, the effect, the consequence was very dissatisfying. You were spanked in the store. So anything that's followed by a satisfying response, responses followed by a satisfying response, are going to be strengthened, more likely to occur in the future. Anything followed by a dissatisfying response or effect is going to be weakened. That response is going to be weakened, and you're going to be less likely to do that thing again in the future. So it's just the basics of law of effect. He tested this idea and others, but specifically the law of effect, with cats and something called the puzzle box. Now, if anybody's ever been around a cat or owned a cat, you know that cats love boxes, okay? But they don't like being put in boxes, okay? If you have a box sitting there, they like to sit in it. But if you shove them in a box, they want to get out. So what he did is he designed these little puzzle boxes, starting out very, very simple with just a little lever. And when the cat pressed the lever, it would open a door and the cat could come out. So the cat can see some food, okay, and go, oh, I want some of that food. And so what it would do is it would kind of just stumble around in the box, okay? It would meow, it would run around, and eventually on accident would hit a lever, and the lever would pull the box up, or the door up, and the cat would get out. Well, cats over a period of time learned through trial and error, okay? If I press this, it opens the door, lets me out, ooh, win. If I press this, that's an error. That won't open the door. Let me try this. Let me try this. Let me try this. And over a series of trials, cats would figure out what exactly they needed to do to get out of the box. So they learned through trial and error. And the observations that were taken from this information was with law of effect. Anytime there was food sitting out and the consequence was the cat getting the food, they would want to get out of the box to go to that food. If the cats were shocked, or if there was something that was dissatisfying, the cat wasn't going to repeat that behavior again. So it wasn't going to step on that lever again, or it wasn't going to try to get out the box that way. So that was kind of the basics. Now we moved to, so this idea started with Thorndike, and then B.F. Skinner is the one who kind of took this behavior, took this information and thought, okay, I believe that, the only thing that's important is observable behavior. He didn't care about emotions and feelings and how people felt and how animals felt and anything like that. All he cared about was strictly observable behavior. And so what he ended up doing was understanding behavior and consequence a lot better, but it's limited. You can't just look at behaviorism and that's it, because it's limited in its scope. But he actually was the one who coined the term operant conditioning, because an operant is any active behavior. Okay, that's referred to as an operant. Okay, and that active behavior, of course, operates on the environment, and it generates these consequences. Okay, so behavior generates the consequences. Now, this is a Skinner box, and there's a YouTube video here, and I believe it's listed on the Moodle page as well. And this is a really interesting little setup, and you can see a couple of the experiments that he actually did. And so it was a really fancy little box that allowed him, and didn't have computers at first. It was just, very basic sort of box, but it allowed him to actually record observations by viewing, but also would mark them automatically. So this is a really nifty box. It allowed him to put a rat or a pigeon or whatever it was that he was interested, or a bunny, whatever he's interested in studying, into the box. And it would have different lights. It would have a speaker. It had an electric grid. So he could do all sorts of things, and it provided food. So he could take the rat and he could, he wanted it to do a particular behavior. So he could show it red lights and green lights. He could do a sound over the speaker. If he wanted to produce a dissatisfying effect, he could actually electrically shock the rat. He can give it food or pellets, all sorts of things. Gave the ability to be able to study rats in a variety of ways. And so when he studied the rats, he used mostly rats and pigeons. When he studied this, he found that there are four basic things that come out of this. Okay, so I'm gonna switch you guys to my full screen, so that way you guys can see both of these things. Okay, so what you guys are going to see here, you're going to see the slides, and then I'm going to show you guys some notes. Okay, so if you know the terms, okay, then this becomes a whole lot easier to understand. Okay, so when it comes to operant conditioning, okay, we have reinforcement, we have punishment, okay, we have positive, and we have negative. Okay, so these are the four basic terms. If you know all the terms, then you will be able to identify any sort of example that's given. And you have to think about, what perspective are we taking? Okay, what perspective are we taking? Are we taking the animal's perspective? Are we taking the human's perspective? Are we taking a child's perspective, parent's perspective, and so forth? So reinforcement means that the idea is that you want to increase a behavior. Okay? Positive does not mean good. Everyone loves to think that positive and negative means good and bad. It does not mean good and bad. In psychology, positive means presenting something, okay, or adding something, okay. Negative means subtracting something, okay. So we're going to start with that, and we're going to come back to punishment. So reinforcement has two kinds of reinforcement. You have positive reinforcement and you have negative reinforcement. And a lot of people get all these terms confused. But remember, as long as you understand the basics of these terms, then you should not have an issue. So reinforcement means you're trying to increase a behavior. So positive reinforcement means you're adding something to increase the behavior in the future. Negative reinforcement means that you are still wanting to increase a behavior, but you're removing or subtracting something from the situation. So positive reinforcement would be, you are making straight A's, okay, and your uncle wants you to continue making straight A's, so you are rewarded with money, okay, to keep repeating that behavior, okay? You're given praise. You're adding something, right, to increase the behavior. So you make straight A's. They're like, great, that's great. Here's $50. You're like, ooh, I'm going to make straight A's again, okay? Negative reinforcement, you want to increase a behavior by subtracting something, okay? So in this case, it would be, for example, when you get in your car and you hear that incessant beeping, okay, that's telling you to put your seatbelt on. The behavior is putting your seatbelt on, okay? You are removing a stimulus, subtracting something, which is the beeping, when you put the seatbelt on. So the idea is that you are going to continue to put that seatbelt on in the future to get rid of that beeping, okay? Another way to look at it is, let's say your mom is nagging you to do the dishes, okay? And she wants you to do the dishes continuously. The idea is that in order to stop the nagging, you are going to, in the future, keep doing the dishes, okay? So the idea is you identify two things in every example. What is the behavior and what is the intended consequence? Is it to increase or decrease behavior? And are you adding or subtracting something? Okay? Very important. Once you understand these terms, then it becomes a lot easier. There's several examples here. One of these examples, this positive versus negative reinforcement, actually shows you two examples in one situation. And it's a mother and a child. And if you take the child's point of view, it's one thing. And if you take the mother's point of view, it's another thing. So that's why I said it's important to see what perspective. you're in a store and you have a crying baby, and the baby is wanting candy, okay, and it throws a tantrum, and you give in, you're going to, in essence, increase the chances that next time you're in the store, the baby is going to cry. And because they know that that produces getting what they want. Whereas, so if you look at the perspective of the child, that's one thing. But if you look at the perspective of the parent, okay, they've just been conditioned by the child. So something else occurs there, which is actually negative reinforcement, okay? So that is the basics of reinforcement. Remember, the idea is you're trying to increase the behavior, and you can do it by presenting something or adding something or subtracting something from as a consequence. I'm just going to delete this because this makes more sense. Okay? Now, when you're talking about reinforcement, of course, you can have two kinds. You can have a primary or secondary. Primary is something that is natural, inherently reinforcing. So food, water, any biological necessity, sex is considered a primary reinforcer, okay? Something that's secondary is something that's learned. You've been conditioned to understand this as a reinforcer. So for example, money is a really good example of a secondary reinforcer, because money, you associate money with being able to buy things. Money is not something that immediately, inherently, you're born knowing that that means something, okay? So you've been conditioned to learn that money can give you something. Tokens, coins, things like that are all considered secondary reinforcers. So moving to punishment. Punishment, the idea is that you want to decrease a behavior, okay? So here we would see that you can actually have positive or negative punishment, okay? A lot of people do confuse punishment and negative reinforcement, but remember, negative reinforcement is to increase a behavior. You want the behavior to occur again. You want people to, put that seatbelt back on, okay? That would be an example of negative reinforcement. You're not punishing the person because you're removing the stimulus. Remember, you're not punishing someone because you want to increase the behavior, okay? And remember, negative means that you're removing something, okay? Now, usually we refer to it as an aversive or something that's unpleasant, but not always, but that's just generally speaking, okay? So we can have positive and negative punishment. Positive punishment would be adding something, right, to increase the behavior, okay? Negative punishment would be subtracting something to decrease the behavior. So positive punishment might be spanking, right? To have that child stop doing that thing. So let's say they're beating up their brother and you spank them, okay? You want to decrease the behavior of them beating up their brother. If it's negative punishment, maybe they're beating up their brother and you don't want them to beat up their brother, so you take away their video games, or TV time, or their tablet, or whatever. So these are basic examples. But remember, as long as you understand these terms, that, increasing behavior versus decreasing behavior, adding to the environment versus subtracting to the environment. This is just a simple chart so that you guys can understand positive versus negative and reinforcement versus punishment. And as long as you think about whose perspective you're taking, then it should make sense in the grand scheme of things, okay? Now, I'm going to skip this really quick, and I just want to, because those are pretty self-explanatory kind of terms. What I want to do is jump to scheduling, because that is something that most people have an issue with, is understanding this. And I want to kind of explain the terms, and I want to explain where this came from. So when we talk about operant conditioning and reinforcement, in the case of B.F. Skinner, he used food, pellets for rats, okay? So at first he used continuous reinforcement, meaning that every single time the rat did something right, okay, he would give it a pellet, okay? And you can actually see this on one of the videos on the pigeon. He wanted the pigeon to do something. So he had this idea in mind, okay? And he wanted to shape the behavior, meaning that every time the pigeon got closer to what he wanted, he would give it a pellet. And so what he wanted the pigeon to do is essentially do a 360. He wanted to go in a complete circle. So every time the pigeon went a little bit, he'd give it a pellet. And a little bit more, he'd give it a pellet. A little bit more, he'd give it a pellet until it went all the way around. And then it was only reinforced whenever it went all the way around. He used continuous reinforcement, giving the food every single time. Problem was, Skinner actually ran out of food. He started to realize that his animals, he didn't have enough money to keep feeding them every single time they got something right. So in his cheapness, he actually discovered something called the partial reinforcement effect. And that is that those behaviors that are reinforced not every single time, but only some of the time, are actually much more resilient behaviors, okay, compared to when they're reinforced every single time, okay? So they're more resilient to extinction. And what that is think about this in terms of something like gambling, okay? We think that, okay, if you play a coin slot, let's say you put a coin in and you do the slot, you know that you're not going to get rewarded every single time, but that's the thrill of it, right? It's going to draw you in and keep you playing because you know you're going to get rewarded at some point, or you think you're going to get rewarded at some point. And so this is partial reinforcement effect. And so extinction for a gambler would be to stop putting money in the slot, right? So by being reinforced every however many times, not every single time, that's going to pull you back, and it's going to make you more resilient to extinction or stopping, and it's going to make you want to continue to play. So another thing that Skinner used to do, just on the side, just to let you know, is he actually used to underfeed the animals, so that way, whenever they would do behaviors, they would be hungry. And so he actually did feed them less than what he should, which was unfortunate, of course, but it did produce some really interesting results of them being responsive to the pellets. They wouldn't get full because they started out really hungry. So this is the example, these are the terms of schedules of reinforcement. So these are all this idea of partial reinforcement. Continuous reinforcement is giving a pellet every single time that animal does the right behavior. Partial reinforcement is not doing that. It's varying it up. Now, again, once you know the terms, you can actually make this, it makes a whole lot more sense. So the terms here are fixed, okay, ratio, interval, variable, okay. Actually, I'm gonna do this. Fixed, variable, ratio, and interval. Fixed means exactly that. It's fixed. It doesn't change, okay? Variable means that it changes, okay? And it changes, it's not the same every single time. Ratio refers to number of responses, okay? And interval refers to time. So very simply speaking, a fixed ratio schedule means that the animal is going to be reinforced exactly when it gives X amount of responses, every fifth response. Okay, it's fixed, every fifth response. It's going to get rewarded. Every fifth correct response, it'll get rewarded. Every 10th correct response, it'll get rewarded, okay? Variable ratio means that it varies, okay? On the 5th response, it's going to get rewarded. Then the 7th response is going to get rewarded. And then the 15th response, it'll get rewarded. And so it varies, okay? It's not fixed, but it's based on the response, on the correct response. A fixed interval is a fixed number of times. So from the start of the experiment to when the animal gives the first correct response is a time period. Okay, so say it's 15 minutes, okay? So once the animal gives a correct response, 15 minutes from that point, the animal will then be reinforced, okay? Every 15 minutes. So variable interval means that the time will vary. So that means that 15 minutes, it'll get reinforced. and then 20 minutes, it'll get reinforced, and 23 minutes, it'll get reinforced, and then 50 minutes, it'll get reinforced. So remember, fixed means it doesn't change, variable means it changes, ratio is based on number of responses, or response rate is probably a better term to use, response rate. Time just means to literally time. You can actually mix these up. These are the 4 basic ones, but you can actually get really, really complex. And we see this in things like those fun little claw machines. They have a very specific time schedule that's based on number of response, amount of money, time that's passed, et cetera, et cetera. And it's a much more advanced schedule. But here, these are just the 4 basic ones. So this is probably these are probably the most, just making sure it's kind of going through. Yeah, those are the most complex terms in all of this. A lot of this other stuff is just stuff that you can read, and you can read in the book. And so just to kind of show that this table here is kind of giving you the comparison of what we talked about today of classical versus operant conditioning and the differences between those two. But really the most important things were those terms that we went over that are harder to understand without reading, in terms of just reading the terms. So I want to give you guys some really solid examples there. So I'm going to go ahead and end the slideshow. If anybody has any questions, now would be a really good time to throw that out there. I'm not getting any chat. I'm not getting any chatter. Let me pull it back up. So if anybody has any questions, now would be a good time. I'm not seeing any questions. So I'm going to go ahead and end the lecture. This will be recorded, and it should be up tonight or tomorrow. And you guys should be able to look at that. I'll go ahead and put the notes on as well, so that way you guys can have those and you don't have to copy all those down. So thank you guys for a great lecture, and I will see you next time. Thank you, and have a great rest of your weekend.